This week we're going to look at a variety of ways for evaluating systems or prototypes of systems. And one class of evaluations is qualitative evaluation. That's contrasted with quantitative evaluation, where we're taking measurements and collecting numbers so we can do numerical, mathematical analysis. Qualitative evaluation is more designed to give you a sense of the usability, or to put you in the place of the user. There's a bunch of different techniques for doing qualitative evaluation, and we'll look at a handful of those in this video lecture. First, let's talk about the cognitive walkthrough. This is something that you can do with an interface or a prototype of an interface. You come up with a description of tasks. You come up with a list of actions that the user has to go through to complete that task, and you develop an idea of a user's background. In this lecture, we're going to have a couple running examples of interfaces and prototypes that we'll evaluate, and one of them will be a low-tech prototype for a gesture-based authentication system for a mobile device. In this case, what are the requirements? Well, we have a description or a prototype of this interface. Ours will be paper-based. The description of the task is simply to authenticate and log in. The actions the user has to take to complete the task is to input a gesture, and our user background is actually going to be a pretty general set of users, from very familiar with technology to those who don't have a lot of background with it. So there's our prototype. When we're working with it, we'll look to see if users know how to perform the action, if they can see the interface control we've given them, if they know that it'll do what they want, and if they understand the feedback they get. So let's look at a video of doing a cognitive walkthrough with this interface. So here's our paper prototype, and you can see I've got two screens developed here. I have this overlay, which allows me to have the setup for when a person's initially creating a gesture to log in. So it says, create a distinctive gesture to log in. It could be a signature or a sketch, just make it memorable. To test this, we'd actually have someone pretend they were interacting with the interface. So they would do their gesture in the middle and click save. Then me, as someone running the paper prototype, would remove this. Now we've saved the gesture, and this is our login screen. It says enter your distinctive gesture to log in. I would do the gesture here, and then we can confirm that the user is logged in. I didn't create a separate page that shows the user is logged in, but that would be a common thing to do with a paper prototype. Now, to do a cognitive walkthrough, we need a description or prototype of the interface. That's what we have here and that I've just described. We need a task description. That's basically to log in. Normally, logging in isn't a great task because it's not the user's goal to simply log in. They want to log in to do something else. But since we're just checking the login system here, we'll make that our task. The list of actions to complete the task would be to click the on button, which I've labeled on the side here. I've drawn it out big like that because if you have embedded buttons in an interface, you obviously can't see that on a two-dimensional drawing. So if the user wants to log in, they would click this on button, they would get this login screen coming up, enter your distinctive gesture, I would enter it, and then the user would get logged in. Now what we want to look for in this cognitive walkthrough is, will users know how to perform the action? Will users see the control? Will they know the control does what they want? And will they understand the feedback? Well, we've got it labeled that they know the control to turn it on, and there's a pretty good label to indicate they should enter a gesture. I think the box is a pretty reasonable indicator that the gesture should be entered there, and we've already shown them this version where they would create a distinctive gesture to log in, so they hopefully know to enter it in the box. Will they know what the control does? Again, hopefully from creating the gesture in the first place, they will know. Will they understand the feedback? Now that's a problem, and that's something that I haven't worked in here. So if I enter my gesture, presumably when I complete the gesture, if it's correct, I'll get logged in. But I haven't added anything in here to handle the case where a gesture fails. So what I might want to do is actually add a new button. We're doing a quick and easy prototype, so I'll actually bring some paper and put a message, login failed. Try again. There's just a paper prototype, so I will just rip that off. So now if the user enters their gesture and it fails, I have a feedback mechanism to show them. That's something that I didn't realize until I did this cognitive walkthrough, but now the feedback makes sense. So there we go. That's a basic cognitive walkthrough of this interface. It actually helped us find a problem with the interface, and we've been able to adapt our prototype to give better feedback.
The next type of analysis that can be done is a heuristic analysis. When you're doing this, you follow rules of thumb or suggestions about good design, and you go through the interface with a set of what you think are representative tasks of what a user would do, and you check to see if those rules of thumb are followed. This can be done by experts or designers, and it's a fast and easy way to evaluate an interface, but it can miss problems that users might catch or identify if they were actually trying to use it themselves. What are those rules of thumb? Well, Nielsen has a list of 10 heuristics. Those include having simple and natural dialogue, speaking the user's language, which means not using technical jargon if you have users who won't understand it, minimizing the user's memory load so they don't have to remember too much, being consistent, and that means consistent within your own application, but also consistent with what users are used to interacting with, giving good feedback, providing clearly marked exits, so if a user doesn't know what they want to do, they can get out, having shortcuts for expert users, preventing errors, giving good error messages, and providing help and documentation. So let's take this list of heuristics and go through and apply that to our gesture-based authentication prototype.
Now let's look at Nielsen's heuristics for analyzing this interface. Do we have a simple and natural dialogue? That's the first question. Well, we can start off with this appearance, create a distinctive gesture to log in. Could be a signature or a sketch, just make it memorable. That word gesture may not be familiar to users, but since we then go on to say a signature or a sketch, that's pretty natural. The save button here is pretty natural, and if you remember, we created this error message. If they try to log in and it fails, login failed, tried again. That's pretty clear. This also speaks the user's language, which is the second heuristic. We want to minimize the user's memory load. That's our third heuristic. Well, the only thing the user needs to remember is their gesture, and this dialogue that we have at the beginning when they're creating it both offers some suggestions. A signature is something people remember pretty easy, and we make sure to tell them to make it memorable. We don't require them to remember much besides that because we give them instructions to enter that gesture when they come back to log in, so they don't need to remember that's what they need to do. Consistency isn't much of an issue here. The only consistency that I can think of is that we have a login screen, which is something that's pretty consistent across mobile devices. We need to give good feedback. Now that's something that we picked up in the previous cognitive walkthrough. We didn't have feedback for when the user failed with their login, so I've added this feedback here, and I think that that's pretty successful. The sixth item on Nielsen's heuristics is clearly marked exits, and that actually is probably a problem. If we go back to our initial screen where we can create a login, there's no option for a user to get out of this. So if they don't want to create this gesture, or if they start creating one and they make a mistake, I don't have any option for them to start over. So that's a problem. So what I could do is create some extra buttons. I could create a little cancel button if the user wants to actually get out of this and not create the gesture at all. So I could put that up here in the dialog, make that a button. And then I also want to have the option for users to get out of having created a bad gesture. So in addition to save, I might create a button that says start over. And put that at the bottom. So then they have an option to get out of this window if they've created a problem. So again, this isn't an error that I made so we could find it going through. It's something that I actually didn't think of when I sketched out this simple interface. So Nielsen's heuristics helped us catch that problem with clearly marked exits. Shortcuts probably don't apply here. This gesture is a sort of shortcut way to log in instead of having to enter a password. We want to prevent errors. Again, this is a pretty simple thing that users are doing. Hopefully we have a good gesture recognition system so people don't enter their gesture and our system fails to recognize it. We need good error messages. That's something that, again, we created here. That's a pretty good error message. We may want to create some if the user is creating their gesture initially and it doesn't meet our requirements, but for now we'll say any gesture works. And we want to provide help and documentation. That's not something you generally do on a login screen like this, and so we may want to make sure that we have documentation either once they're in the phone or in the setup process. So there you go, a heuristic evaluation of our gesture-based login system.
Another way of doing qualitative evaluation is with personas. In this method, you come up with fictitious users that represent a class of users. They become a reference point for design and analysis, so that prevents designers, programmers, and other people who are thinking about an application from referring to themselves too much. Your persona has a goal or goals that they want to accomplish, either in general or within your system. Here's an example of a persona that we've put together. This guy is called Frank. His goal is that he wants encryption, but in simple, low-effort way. His overall goals is that he wants to use email and social media tools that are encrypted to protect his privacy. So we know what he wants within a system, and then we've got some background about him. So clearly he's a male, he's an undergraduate student who's 21 years old, he's a psychology major and a political activist, he's a savvy computer user but not an expert, and then we have a little biographical paragraph about him. Frank's an undergraduate at the University of Maryland. He enjoys playing baseball, swimming, and watching movies. He carries an iPhone, and he has a laptop and a tablet. He's constantly connected, and he's a frequent social media user, but he's also a political activist, and he worries about his communications being monitored. That part of his background clearly plays into the goals that he has. When you're designing a system and you're using a persona, you want to think about who this person is, and then look at your system and ask, does this person have the skills necessary to use the system? Does our system meet his goals? Would it be something he's able to do? And having him as a reference point, along with a set of personas that are developed to represent all the different classes of users you might run into, allows you to evaluate a system from the user's perspective, even without bringing users in. Let's use Frank's persona to analyze our login system. Now, even though his goals are for encryption, we can still use his background as one that will be useful to understand our login system.
So finally, let's do a persona analysis. We have our revamped screen to create an initial login, and we're going to see how well this would work for Frank. So he's an undergraduate student, he's a psychology major, political activist, and he's a savvy computer user but not an expert. Would he know how to do this? Coming to this, he may not know what that word gesture means, but again, since we said that it could be a signature or a sketch, he probably would be able to figure out, as a savvy computer user, that he would draw with his finger in here. We know that he has an iPhone and an iPad from the persona, so he's used to a touch-based interface. So likely he would figure out that he could draw in here. However, talking through this, it makes me think that some users might not understand to do their gesture in the box. So we could put a little prompt message that says, draw gesture here. And that could be a message that starts off on the inside of this box when the user is creating their gesture. So before they start, it's a little message to let them know to enter it there. And once they start gesturing, that message actually disappears and they're allowed to finish. So that's something that could make it easier for users to understand what to do. Now his goals in the persona are to have encryption and security to protect his email and his social media. That doesn't really apply here, but he's likely security conscious about his devices too. So as long as this is a secure way of logging in, it probably goes and meets his goals. So there we go, that's a persona-based analysis. We have a pretty simple interface here, so there's not a lot to discuss, but looking at those insights from Frank's background did give us a little bit to think about in terms of the design.
So in conclusion, qualitative evaluation can provide insights into the usability of a system without needing to do measurements or timing. There are various levels of complexity. Some of them, like a heuristic evaluation, can be pretty straightforward, but developing good personas can be something that takes hours to do, and a team may spend a lot of time building the personas and doing the analysis. Some types of qualitative evaluation can be quick and inexpensive, but they may miss insights that users provide. There are also types of qualitative evaluation that include users. We're not talking about those in this lecture, but when we move on to talking about usability studies, we will look at studies that involve users, and those can be done both in a qualitative or a quantitative way.
In this lecture, we're going to talk about running controlled experiments. This is a great thing to do on your own if you're trying to analyze the usability of a system, but a lot of components of this fall into other types of analysis which we'll do to analyze systems. So there are a lot of lessons here. Let's go through the process of running controlled experiments. We're essentially going to use the scientific method. We start out by stating a lucid, testable hypothesis, and we're going to go through examples of all these stages in this lecture. Once we have our hypothesis, we need to identify independent and dependent variables. That's what kind of things are we going to alter and what kinds of things are we going to measure. Then we design the experimental protocol. That's the actual steps of the experiment that we're going to carry out in order to test our hypothesis. Then we choose a user population. These are hopefully the same people who would be using our system, but if those people aren't available to us, we should choose someone who has similar experience, awareness of the context and environment they'll be working in, or a technical background. The next stages are first to run some pilot participants. These can be anyone. Bring in some people who are friendly and have them go through your experiment before you unleash it on the world. Every single experiment I've run, and I have run hundreds of them in my life as a researcher, has had problems in it the first time around. You have to run a pilot experiment because there will be difficulties with your instructions, things will be unclear, people will do things incorrectly, you will have trouble measuring. There are tons of things that can go wrong, and something always does. So if you run a pilot test, where you have some participants come in, try to do the test, and get some feedback, you will be able to refine your experiment to make it more effective. Fix your experimental protocol after you've done the pilot test, and then you actually run the experiment. You're going to collect data from all of your participants, and when you're done, you perform a statistical analysis. That will let you know if you have real results that have meaning, or if there's not any difference between the conditions that you tested. Finally, you draw your conclusions and communicate your results.
Recall the experiment that we did when we were studying usability, and we wanted to see if it was faster to log into the iPhone using a thumbprint authentication versus typing in the PIN. We had the same user do both, and we timed it, and in the example of this user, we found that it was much faster to log in with a thumbprint. But is that universally true? In this lecture, we're going to do a controlled experiment that you all will participate in, and we'll compare the biometric versus PIN authentication, and for those of you who have Android devices, we'll have a third data point for gesture-based authentication.
So let's start with step 1, stating a lucid, testable hypothesis. In this case, we're going to use the example that a mobile phone login using a fingerprint is faster than with a PIN entry. This is easy to test, and it's very clear. We're going to time how long it takes to log in with a fingerprint and time how long it takes to log in with a PIN. Next, we need to choose the variables. We need to pick the independent variables, and these are the things that we manipulate, the things we change. In this case, it's our login method. Our users will log in either with the PIN or with the thumbprint. Our dependent variables, the things that depend on what we're testing or the things that we're measuring, in this case will be the time to log in. It can be confusing to remember independent and dependent values, but if you remember that there are things that you're manipulating and things that you're measuring, you want to have a list of both of those. Next, you design your experimental protocol. That's actually the steps that people will go through when they're doing your experiment. When you're doing this in HCI, you need to choose the tasks first. So if you're analyzing the security of a system, like the authentication system, what are the tasks that a person will do? Well, if we're trying to authenticate on a mobile device, the only task we're going to be testing here is to log in. But you can have a lot of different things going on in your system, and you want a task for each of those. We talked about tasks when we were discussing usability in the first week, and these can be similar tasks to those. You want clear, concrete things that a user would do in your system, and those become the tasks in the experiment. You then want to ask if you're going to do a between or within subjects experiment. In a between subjects experiment, each subject does one condition. So if we did a between subjects experiment for our phone login, half the people would log in with the PIN and the other half would log in with a fingerprint. A within subjects experiment has each subject run multiple conditions. So in our experiment, the same person would log in both with the thumbprint and with the PIN. Within subjects experiments tend to be more desirable, but there can be some learning effects, so you want to make sure that your users are doing things in different orders so they don't get better at tasks in one condition and then perform well when they do that same task later under a different condition. The experimental protocol for this experiment is spelled out on the form that you all will complete. If we look at the text zoomed in, it says, using a stopwatch timer, precisely time how long it takes you to log into your mobile device. Begin with the lock screen visible. Start the timer as you start authenticating and stop the timer when the home screen appears. These instructions actually evolved out of doing pilot testing because in the first set of instructions it was unclear whether or not the phone should be completely off or whether or not you should be on the lock screen, and it was unclear when you should stop the stopwatch. So these instructions came out of the pilot testing. Users will make their timing following these instructions and then enter the results on this form, which I'll discuss later in the lecture. Once you have your experimental protocol put together, you want to run the experiment. You should have done the pilot study, and then you want to have a checklist of all the steps so all the users are doing the same thing. I have a pretty simple set of instructions because this is a pretty straightforward experiment. However, often you'll have users doing multiple tasks, and you want to have a list so you give exactly the same instructions to everyone and you have them do the same process. If you don't have that list, it's likely that you'll forget something, and that can manipulate your results so you don't get anything accurate at the end. Going through your checklist, have everyone do the experiment, collect your data, and then you're ready to actually do the analysis. It's important when you're doing a quantitative experiment that you do a statistical comparison. A t-test is an example of a simple statistical test. We're not going to get deep into statistics in this course, but I will give you an example of how to do a basic t-test analysis. So here we're looking at an Excel spreadsheet with the example data from our test. We have 10 users who've entered the data, and we have the time that it took for them to log in using the biometrics and the time it took them to log in using the PIN. Now the first thing that we want to do is just see what the average time was for each. So we can use the average function from Excel, select the data from the column, and here we see for the biometric the average time is 1.44 seconds. We can just copy that formula cell, and we can then see that the average PIN login time was 3.45 seconds. Now, at first glance, it's pretty clear that the PIN login time is a lot longer than the biometric time. But in order to actually say that there's a difference, we have to show that it's significantly longer to log in with the PIN than biometrics. And it doesn't matter how big a difference there is in those numbers, you actually have to do a statistical test. In this case, we're comparing two populations, the test with biometric and the test with the PIN. Since we have two groups and we want to see if there's a significant difference between the average time in each, we can use a t-test, which is a standard statistical test. It gives you the probability that the difference that you see in those two averages is something that would happen by chance. So if we use a more simple example,
pretend that our biometric login time was 1.44 seconds and the PIN login time was 1.45 seconds. Yes, 1.45 is larger than 1.44, but that difference is so small that it could be attributable to one person happening to take a tiny bit longer or having a tiny bit of difference in starting and stopping their stopwatch. The t-test actually shows us if there's a real difference there or if it's too small to be considered significant. The way that you run this is to use the t-test function. This is built into Excel, and you first select the first set of results, then the second set of results. If you click on the t-test option here, you'll get a set of options that you can put into this formula. I know what those options are. You can read a little more about them. I'm going to do a two-tailed t-test, and I'm going to do it as type 1. Again, if you click on this link that pops up when you start entering the formula, Excel will explain a little bit more about what those last two values mean. But what we end up with after running the t-test is this value. Ours is 0.001. That's the probability that the difference between these two means is due to chance. In other words, there's a 1/10 of 1% chance that this is simply random difference between the time to log in with a PIN and the time to log in with a biometric. That's a pretty small probability. In general, for a t-test, if this number is less than 0.05, you can say there's a significant difference between the means. If it's greater than 0.05, you can't say there's a significant difference. What that means is there has to be no more than a 5% chance that the difference between those means is just random. In this case, our result is 0.001, which is a lot smaller than 0.05, so we can say we have a significant difference. Once you've done your analysis, you report your results. So now that we've seen this process, let's actually do it. You're going to follow those instructions, time yourself, and enter your data into the form that's linked on the website. If you go to the section of the website that has that link, you'll be able to see the instructions so you can go over them before you time yourself and enter your data. We've got this set up so if you have an iPhone, you can enter your thumbprint authentication versus the PIN, but if you have an Android, you can also do the gesture-based authentication, and we'll collect all that data. When you're done, you'll see that there's a link for you to check out the results, and that'll include some statistics like the t-test that we looked at before, and those are also linked on the site. So this is an example of how you do an experimental analysis.
So today we're going to be talking about how to run a usability study. This is a fundamental part of analyzing the usability of a system, whether it's a security system, a website, or a mobile application. Usability studies analyze how usable a system is. When you're evaluating it, you want to look at the aspects of usability that we talked about earlier. That's speed, efficiency, learnability, memorability, and user preference. We're going to study those by having users sit down in front of your system, use it, do some normal tasks, and collect data on each or some of those aspects of usability. When you're testing the usability of security, it's important to realize that security is rarely the task that users set out to accomplish. Security should just be part of the background. So good security is really a seamless part of other tasks that users are trying to accomplish. And we'll see some examples of good and bad tasks that can test how usable the security features are without trying to put them too far forward. So the usability study process goes like this. First, you define tasks and their importance. We talked about tasks in the first week of class, and the important thing here is that we come up with a set, usually around 5, maybe a few more or a few less, that represents the normal things people would do with the system. You want to find the most obvious tasks and put those first. For example, if you were studying Google, one of the main tasks you should have on your usability test would be to have people conduct a web search. After you've developed your set of tasks, and we'll talk more about those in a minute, you need to develop questionnaires. Some of those will collect data ahead of time that has things like demographics and experience. Post-test questionnaires that go after the study ask people for their feedback about how easy it was to use the system and what they liked and didn't like. When you select tasks, you're really doing the most critical part of running a usability study. People will sit down and they'll do the tasks that you give them, so they need to be well chosen and well articulated. As I said before, you want to pick tasks to be the most important things that a person would do with an interface. When you're presenting tasks, you want to make sure that you avoid some common pitfalls that people often have when they're learning how to do usability studies. First, you need to present your tasks as an actual task, an action, and not a question. This is a common mistake that people make when they're learning how to do usability studies. A good task would be something like, create an itinerary with flights from BWI to Las Vegas, departing December 30th and returning January 5th. It's specific and it's an action that the user would go into a website to take. A bad task is, how many flights are available from BWI to Las Vegas, departing on December 30th and returning on January 5th. People don't go to a site to count the number of available flights, so your task shouldn't ask them for a number. People do go to a site to find flights that are available, so the task should reflect that. And this is a lesson you want to keep in mind for all of the work that you're doing when you're building tasks. Ask yourself, is this something the user would go to the site to do? And really look at the way your task is presented. You also want to be specific. So the previous example I gave you is specific. Another good example would be to find the calories, vitamins, and minerals in a 1 cup serving of broccoli. That's a specific task. A bad task would be find nutrition information. You haven't said what information you want them to find, you don't know what the food is that they're looking for, and that leaves users kind of wondering what they're supposed to do. They don't know when they've completed the task and they're not sure what you're looking for. So your users shouldn't have to do any work to figure out what you want them to accomplish. That said, it's important that you're not giving instructions in your task. So another example of a good task would be to use Google Maps to find a street view of the Empire State Building. A bad task that's too specific would really give instructions on how to do that. It might say, go to maps.google.com, in the search box enter 355th Avenue, New York, New York, click on search, then using the zoom scale on the left side of the map, click the person icon to see a street view. That's just telling the person exactly what to do. So you're not testing the system, you're really testing if the user can follow your instructions. So you want to make sure that your tasks are a thing a user would come to the site to do. They wouldn't come to the site to follow that set of instructions, but they would come to find that street view. Finally, you don't want to be vague or provide tiny, insignificant tasks. So another good task would be, using Google Maps, find a close-up view that shows just the block with the Empire State Building. A bad task would be, zoom on a Google map. It's true that people might zoom when they come to the site, but the reason for going to Google Maps is not to execute the zoom feature. It's used as part of some greater task. So you want to make sure that you don't focus on little features that you want to know the usability of, and make a task that's not actually a realistic thing that a person would come to the site to do. You want to choose representative tasks that reflect the most important things users would do in the interface. So for Google, as I mentioned, that could include things like searching the web, searching for images, creating an account, looking for directions. Bad example of task would be to do 5 basic web searches for different things. So search for broccoli and search for information on sheep and search for the date of the next full moon. You're just having them do the same task over and over again with slightly different parameters. So your task should really cover the breadth of things that people are going to do on the site and highlight the most important ones. When you're looking at security tasks, it's important to remember that security is almost never a task in and of itself. So if we were looking at a secure system like a banking website, a good task could be check your balance or make a transfer. A bad task would be log into your account. Now it's true that people will have to log into their account to do something on the site, but no one ever goes to their banking site where their goal is, I'm going to log in, and that's it. They may have to log in order to be able to undertake some of the other functionality, but logging in by itself is not a primary goal that someone has with the site. So that's a security feature that we may want to test the usability of, but you can't pretend that it's a task or a main goal that a user would have on the site. Instead, security should neatly run into the flow of normal tasks that people are trying to do. In this case, if someone wants to check their balance and they're not logged in, they'll have to go through the login procedure and you'll be able to see how usable it is. But they shouldn't focus on logging in as their main goal. They should focus on the actual tasks that they want to perform on the site. Once you have your tasks developed, the two things that you have left to build are pre- and post-test questionnaires. A pre-test questionnaire will have any relevant background questions that you want to ask your subjects. That could include things like age, gender, education level, experience with a particular type of website. You may also want to ask more specific questions, like whether people are colorblind, if the user has children. It depends on the site that you're trying to test and the functionality that you're interested in your tasks. Don't ask anything that's irrelevant, but if something is really important for the kind of site you're testing, put it on that pre-test questionnaire so you have it as background. Your post-test questionnaire is going to ask questions about what people's experience were doing the tasks. You may ask them to rate how difficult or frustrating or easy it was to complete the tasks. We often ask people to do this on what's called a Likert scale, which is a 5 or 7 point scale where they can just circle a number. The endpoints are labeled like easy to difficult or frustrating to intuitive. That questionnaire goes at the end, and we'll see some examples of that later in this lecture. Once you've got the tasks and the questionnaires, your evaluation is going to take place. The users are given the list of tasks after completing the pre-test questionnaire, and they sit down with the system and just go through and do each of the tasks. Their interaction is governed by some different ways of observing them, what we would call observation protocols. There's 3 major observation methods or protocols that we do when we're studying usability tests. One is called the silent observer. In this example, you, the experimenter, basically stand behind the subject who's undertaking the task and watch them do it. They don't say anything, you don't ask them any questions, you just watch and take notes. So we're going to pretend we're doing some usability studies. You get to be the experimenter and I get to be your subject. I'm going to sit here using the system and you'll observe me. I'll let you see both from the experimenter's perspective that you're seeing here, and you can also see some clips of what I'm doing on the screen. The task that we're going to have me complete here is to look at the dashboard of courses that I have set up in Coursera. So this is a system you all should be familiar with. We're going to go through each of the different observation methods, and we'll start with Silent Observer. With the Silent Observer method, I'm simply going to try to log in and see the list of courses. You're not going to hear me say anything, you're just going to watch, so we'll do this pretty quick. And that's it. This is my list of courses. The second method is the Think Aloud method. This can be a little uncomfortable for users, but it's really helpful and insightful for you. In the Think Aloud method, users actually sit down and talk through each of the things that they're doing. Every part of their thought process gets articulated, and so you get to see what they're thinking. A lot of times you'll find that when you're watching people, they'll do stuff that you don't expect and you have no idea why they did it. But in the Think Aloud method, they actually explain what they're doing so you can get some more usability insights. So here we are back at the home screen, and now we're going to go through what it would be like to do the Think Aloud method. I'm going to do exactly the same task, but you're going to see what it would be like if I'm using that protocol. Okay, so I need to see my list of courses, and for that I probably need to log in. I see that there's a sign in button at the top, so I'll click that. I think my email for this is my main university email, and that I use a common password. Alright, so now I'm here on the main page. I think this is a list of my courses here. And if I want to see if there's other ones, I put my mouse over my account up here. That's a pretty normal place to find it. And I see there's this course dashboard. If I click on that, nothing happens. Maybe that's where I am already. So I'm going to say that's it. I'm done with that task. And that's what you would have subjects do for every task through to completion if they're doing the silent observer method. And then finally, there's a constructive interaction method. In this way of observing people, you can have two users working together, or you can be asking questions and offering suggestions without telling the user how to do the task. It allows a little more interaction, and you can see how people work through problems that they may have using your application. Finally, there's constructive interaction. Now, this is a little harder for me to simulate since there's just me here and you, the experimenter, can't talk to me and I don't have a partner to work with. But I'll show you an example of some of the questions that I might ask, and you can think of some answers that you would give me either as the experimenter or if you were a partner sitting down and working with me. Okay, so I'm going to sign in using this button up here. We can use my account. Okay, so I get here and I can see that I have a section here called Your Courses, but I'm not sure if that's all of them. So do you think there's somewhere else that maybe I should go to look at this? We could try going here and looking at the course dashboard, and that doesn't seem to go anywhere, so maybe this is it. Maybe this is the main place that we want to look for that. And so that's it. Those are the kinds of questions that I would ask, and if I had a partner or a participating experimenter working with me, we would answer those questions, maybe offer some feedback on the actions that I was taking. So there you go. That's constructive interaction. When you're done with the test, so everyone has gone through, done all the tasks, and you've taken your notes, you'll administer your post-test questionnaire, and then a lot of times we try to do an interview. This can be really short, but we often find when we try to run usability studies that people aren't willing to write you long paragraphs describing their experiences, even if they have thoughts, because it's just not fun and it takes them a lot of time. But if you ask them questions, if you just ask, what did you think of the site as a general question, or if you have some more specific ones, they're a lot more likely to tell you in an interview format. Take notes, or if you're making video, you can go ahead and record that, and that'll give you some extra things to think through when you're analyzing the usability of your site. Once you've done all that, you want to report your results. So you take your evaluation, everything that all of your users have done, report that out. You want to summarize the experience of your users. Now you can do a usability test with only 1 or 2 people. That's a little bit small because you may not catch all the usability errors. But it turns out you only need a few more than that to actually cover a lot of the usability problems with an application. 5 or 6 people often will give you all the insight that you need. You want to summarize their experiences, emphasize your insights with specific examples or quotes. So if people had a lot of trouble with one particular task, take some quotes from your exit interview, take some things that they maybe said while they were doing the task, and report that. And then offer some suggestions for improvements on the tasks that gave people real difficulty. So that may be, it turned out that logging in was quite hard. You want to make sure that you can offer some suggestions on how to make that easier. Finally, here are some lessons that we can take from how you actually conduct a usability study and what it's good for. You want to look at what parts of a site or an application are easy to use. That's ultimately your goal. As a designer, you may not really understand that, but your users will be able to go through the tasks and tell you what's easy and what's hard. You can come away with that with an understanding of how usable the site or application is for each one of the tasks that you have people complete. You can also come up with suggestions about what improvements can be made to improve usability. And in the security context, you can get additional insights into how you can make the security a more seamlessly integrated part of the site as a whole. So usability studies are a great tool for understanding these usability problems. They're very low cost, they're easy to run, and with a little investment in time, you can actually identify and correct a lot of usability problems with an application you're building just by running this simple test.
In this lecture, we're going to talk about A/B testing. This is a type of testing that doesn't rely on any cognitive or psychological understanding or model of user behavior. Rather, you just show users two or more options. That is where the name comes from, option A and B. And you put both of those options live on the web or live in your application and measure how well they perform. You can actually find tremendous differences in performance based on very tiny changes in the way the interface works. This can be done to measure which sorts of security features like authentication mechanisms are more effective, but it can be used in all kinds of ways. The process is quite simple. You show people different options and you measure the performance. But I think it's easiest to understand by looking at some good examples. I'd like us to start with this example from the Obama campaign. There's a reading for this week that's linked to a blog entry about exactly this campaign, so you can get more details from the company who ran this test to see more about what they did. But let's start with this page. This was the main welcome page when people came to Barack Obama's presidential website in the 2008 campaign. And this is the default page. So you came there, you were asked to put in your information, and you can note that at the bottom you have this option to continue to the website. So you don't actually need to fill out your information here, but you can, and that puts you on their mailing list. The first thing that was measured in this study is if we could change the text of this sign up button and if that would make a difference. So there were 4 buttons that they used. Sign up was the default, that was the original button, and they tried replacing that with buttons that said learn more, sign up now, or join us now. A certain percentage of users saw each kind of button. They were randomly assigned to one button or another when they came to the site. And I think an interesting thing when I talk about A/B testing in class is to see what your perceptions are versus the reality. Because often I have students who are completely wrong in every guess they have about which thing performed better. So I'm going to always show you the options first, ask you to guess which one of these things did best, and then we'll actually take a look at the results. So sign up is the default. We have 3 alternative buttons. Think about which one you think would do better. And then let's look at the results. So compared to the response rate that they were getting with the sign up button, using the button that said learn more led to an 18.6% increase in the number of people who signed up. However, using sign up now led to a 2.38% decrease in the number of signups, and join us now led to a 1.37% increase, which is a small increase, but nothing as dramatic as what we got with learn more. So that's pretty interesting. And this gets to one point which is both frustrating in some respects and simple in other respects about A/B testing. We have no idea why one of these performed better than the other. We can come up with theories, but ultimately there's no insight into the why. There's no explanation that comes from A/B testing. We simply know the result that one button performed better. In the same test, the researchers looked at replacing this main image with either a video or an alternative image. What we're going to do now is look at the videos and images that they had, and then we'll take a guess about which one did better and look at the results.
The pundits like to the red states.
It's been a long time since I wanted to hear what a politician had to say.
You came here because you believe in what this country can be.
Hi, I'm Barack Obama. Welcome to BarackObama.com, the official website of my campaign for president. Here you can sign up for invitations to campaign events and learn more about our movement for change.
And finally, there are two images, this one called the family image, and this last one called the change image. All of these were shown as replacements for the main image that we saw originally. So which performed better? Make your guess, and now we'll look at the results. So our first row here shows the original image. Obviously that doesn't improve on itself. And then we see the order of performance for the other options. The family image by far had the best improvement. It had a 13.1% improvement in the number of people who signed up. The change image did a little bit better than the original with a 3.85% increase. And all the videos had a decrease in sign up. And in fact, the interesting result is the videos designed to be more inspirational. Sam's video, which was the long one that we saw first, and then the Springfield video, both had really dramatic decreases in the number of people that signed up. Again, we can come up with theories about why this is. For example, people might get tired of watching the video and just leave the site instead of signing up. Or they might click through using that link that doesn't require them to sign up. But we don't really know. We don't get any explanation for why with A/B testing. We just get the results. Let's look at another example. This is the National Alert Registry, and it's a registry that people can sign up for and get updates to. This is their main page, so you can see registered sex offenders listed in the area, you can sign up to get a report, and there's credit card information at the bottom. If you look at the bottom of this page, there's actually a link here that will take you to a website that talks about the design and redesign of this page. So they started off with this original design, and they created a couple alternatives. The second option looks like this. It's a pretty small change from the previous one. If we click back and forth a couple times, you can see the font changes, and there's a little bit of layout difference. The text here on the original changes to a slightly shorter bit of text. But overall the site looks about the same. Finally, they tried a third layout. This goes into a 2-column format, so the sign-up information is more clearly in the center, and some of the information that was at the top is now moved into a parallel column. Which one of these three do you think had the biggest impact on the number of people who signed up? Well, if we look, here are our three options side by side, so you can compare them. Basically, the first two are very similar with a few changes in language. The third one changes the layout. And what we see is that for the period that they tested, the original generated 244 new sales. The second option, which had this click here text added, increased sales by 15.5%. They had 282 new signups. In this third option, with the parallel bits of text, new sales were only 114. That's a 53.3% decrease in the number of people who signed up. So these very small changes actually can have a huge impact on the way users behave with a site. Here's one more really simple example. Dustin Curtis is a UI designer and he has a blog, and he did his own A/B test on his blog asking people to follow him on Twitter. And he had 25% of people assigned to see each of these 4 different options. The first one just says, I'm on Twitter, with a link to Twitter. The second one says, follow me on Twitter. The third says, you should follow me on Twitter. And the fourth says, you should follow me on Twitter here. Now, when I talk about this with HCI people, they all kind of cringe at this last option because we're kind of taught that you shouldn't use the word here as a link, because if people are scanning through text for the underlines and they see the word here underlined, it doesn't tell them anything about where they're going. The 3 other options have Twitter as the link, and that lets them know that it's going to Twitter. Which one of these 4 options do you think got the most people to follow Dustin on Twitter? Well, here's the performance. Here we're seeing the percentage of people who followed him out of everyone who saw each of these options. The first option, I'm on Twitter, did the worst, And the last option that has that here underlined, even though it goes against some guidelines of good web design, had a much, much better performance, performing about 3 times as well as this original option. Here's an example from a presentation given at Microsoft called Practical Guide to Controlled Experiments on the Web. Here, they were studying how often people filled out feedback in their Office Online feedback form. This is the original form, so the response rate here gave them their baseline for comparison. They looked at 2 alternatives. This was option A. Option B had a 2-stage response. You could click on a star, and then after you clicked on it, you were given a box that had your rating and you could write a comment. Option C asked you a simple question: was this information helpful? Yes, no, or I don't know. And then based on which of those buttons the user clicked, they were given a different box with a question to actually write a comment and submit it. Which of those 3 options do you think did best? So option A, B, and C. Option B with the 2-stage response had double the response rate of A, the default. And option C had 3.5 times the response rate of B, so over 7 times the response rate of A, which really shows that even though A is a simple interface and in fact has the same options as the other 2, the way that it's presented has a huge impact on how people respond. And here's one final example. It's from the same presentation, and the researchers here were comparing the performance of MSN Live Search. Now there's 2 windows shown here, and they have the 2 variations that were being tested. Can you tell what those variations are just by looking at the window? It's actually really subtle. The main difference is in the colors, and you can see it most clearly in the text of the links. Here it's a kind of tealish blue, and it's a more bold blue in this second example. If there's any performance difference, it's one of those things that's actually quite mysterious to us as user interface designers. The differences in color really don't have an impact here on the clarity of what's going on in the site. It's not like one color text indicates a link more clearly than the others. It's pretty straightforward in both examples, and in fact, just looking at it, it's almost impossible for us as users to even see the difference between these 2 sites. So why would there possibly be a difference in the performance that you see from users on each of these 2 sites? Is there one? In fact, there is, and it's pretty big. The number of queries per user is 0.9% higher with the second example, and that may not sound big when you have millions and millions of people coming to your site. That results in thousands of additional searches. More importantly, the number of ad clicks per user increased 3.1% with the slightly bolder colors in the second example than there were in the first example. Why is this the case? We don't know, and I think this example in particular highlights some of the frustrating parts of doing A/B testing. There's clear and obvious differences in the performance here, but there's very little to suggest why that might be the case. So here are some details on how to run an A/B test. First, you want to start with a small percentage of visitors trying your experimental conditions. Don't create 2 conditions and launch half the site with one and half the site with the other. Start with, say, 0.1% of people seeing the experimental condition and then ramp it up. You want to do that so you can automatically stop testing if any condition has very bad performance. For example, if you have something that drives away half your visitors or half your customers, you don't want to have that test running on a huge group of people for a long amount of time. Start it with a small group, and if it looks like it's doing okay, then increase that number until eventually you're testing with half your visitors. Finally, let people consistently see the same variation so they don't get confused. If you're changing the appearance and layout of your site and a person comes to the site and sees option A, comes back later that day and sees option B, it can be really confusing. So you want to make sure once a user has been put in an experimental condition that they remain in that same condition for return visits. Google Analytics allows you to easily do A/B testing, and they can keep track of what condition people have been put in and keep the interface consistent for them on return visits. So in conclusion, small tweaks to an interface can lead to big differences in user behavior. We saw that in all these examples that we looked at today. A/B testing allows you to check that difference in behavior by showing alternative versions of the site to people. So different groups see different versions of the site, you measure the performance of those groups, and that allows you to make conclusions about what version of your site is most effective. You don't get any explanation about why that difference leads to the change in behavior, but it's still really useful data to tweak your site and improve its performance. In this video, we're going to look at a case study of phishing warnings. This case study is based on the assigned reading that you'll see linked on this week's Coursera lecture for the paper titled "You've Been Warned: An Empirical Study of the Effectiveness of Web Browser Phishing Warnings." Before you watch this video, you should read the paper. It's a great piece of HCI research exactly about security issues, and once you've read it, you'll have a better understanding of what we talk about in this video. So let's start by talking about what phishing is. Phishing is a practice where websites pretend to be a different site that a user trusts in order to get them to enter sensitive information like login credentials or financial information. Web browsers are able to detect this, so if I enter the URL for a phishing website, the browser can bring up a message that says this page is a reported web forgery. It gives me a security message. This one is in Firefox, and it says this web page at www.itsatrap.org has been reported as a forgery and has been blocked based on your security preferences. It then goes on to explain to the user that web forgeries are designed to trick you into revealing personal or financial information by imitating sources you may trust. Entering any information on this web page may result in identity theft or other fraud. We then have buttons to get me out of here, go somewhere safe, get more information about why the page was blocked, or down in the corner is a small link to ignore the warning. If we were to click on that, fortunately, this is an example page that isn't actually phishing for us, and we get brought to a more explanatory page at Firefox that says what's going on here. You can also see that Firefox has added a red bar across the top because even though this website isn't really phishing, it's there to serve as an example, and it's on the list of blocked sites. So users are warned the entire time they're interacting with a forged site that there's danger involved. In this study, the goal was to see how effective these different web browser phishing warnings were. Now, if you remember from our previous lecture, we measure usability in 5 main ways: speed, efficiency, learnability, memorability, and user preference. Now, when we're looking at security websites and security issues, we often measure how secure a user's behavior is. And that's not a thing on this list. We're not including user secure behavior on the list of usability. So how do we reconcile those things? Well, if you think about it, taking insecure behavior, for example, entering information into a phishing website, is essentially a mistake the user's making, and it's a mistake that could be prevented by the interface. That's what efficiency measures. So essentially, when we're looking for security mistakes that users make, we're measuring the efficiency of the security features of a website or application. This study created 2 phishing websites, one that mimicked Amazon and one that mimicked eBay. We're looking at the actual sites here, but the ones that they created had slightly different URLs, and they registered them so the browsers would know that they were phishing websites and try to block them. They didn't actually collect any personal information from the users, but they had the ability for users to enter their login credentials. The researchers wanted to see how effective each of the different browser phishing warnings were in preventing users from entering their personal information. The browser warnings that they looked at were the following. The first is Internet Explorer's active phishing warning. This is called active because the actual site you're going to doesn't come up. Instead, you get this page that only has the warning appearing on it. Next is Internet Explorer's passive phishing warning. This is passive because the page actually loads in the background, and instead you just have this small pop-up window that says it's a suspicious website. The third browser option they looked at was Firefox's phishing warning. This is a little bit different than the one we just saw in the example because they had an older version of Firefox, but you can see that the text is similar to what we saw in our phishing example. The page shows up, but it's grayed out in the background, and the main thing you see on the page is this window that says you're looking at a suspected web forgery. Again, you should have read the paper, and I'd suggest you look closely at the text and appearance of all of these windows because it will give you a good idea about what's going on with each of the warnings. The study was then relatively straightforward. People were put into each of these 4 groups. They looked at the Firefox phishing warning, the active one from Internet Explorer, the passive one from Internet Explorer, and there was a control group who used a browser that didn't show any phishing warnings at all. The participants in the experiment received emails that pretended to be from either Amazon or eBay that told them they had to log in or else an order would be canceled or something would happen with their account. The numbers that we're looking at here indicate what percentage of users clicked on the link in the email and what percentage of users actually entered information into the phishing website and submitted it. In Firefox, 100% of the users clicked on the link, but 0 of them actually entered information into the phishing website, which indicates that Firefox did a great job of explaining to users that something wrong was happening and that they shouldn't enter any information. Internet Explorer's active phishing warning was the next best option. 95% of those users clicked on the link, but only 45% of them actually entered information and submitted it to the phishing website. Now that's a lot worse than Firefox, but it's much better than the other 2 options. In both of those cases, 90% of people entered phishing information into the websites. That means Internet Explorer's passive phishing warning was no more effective than having no warning at all. Now these are pretty interesting results, and this is a great example of a nice empirical study analyzing the effectiveness of these different tools. Essentially, it's analyzing their usability to keep users from making security errors. But another great thing about this paper is how they linked this to mental models. If you remember the first week of class, we talked about the importance of mental models to HCI, and we looked at some traditional psychological mental models. In this paper, the researchers actually pull mental models from the community of people who study hazards. And what we see on the slide here are some facets of this CHI-P mental model that they use. This looks at how people pay attention to and react to warnings about hazards. It includes things like how to get their attention and hold it, how to make sure they comprehend the warning and remember it, what are their attitudes, beliefs, and feelings about it, if they're motivated to respond to the warning, if they actually perform the actions that they should, and how other environmental stimuli change how they behave. The researchers do a great job in this paper of looking at the presentation of these different phishing warnings and connecting it to this mental model. The conclusions that we can draw from this are, first, that the interface can have measurable impacts on the usability of security features. In this case, we saw that, for example, Firefox's phishing warning was far more effective than any of the other ones. And this shows us that better interfaces lead to more secure behavior. We have an empirical study that proves that, and we have a nice tie-in that shows from mental models that active warnings are able to capture and hold more attention than the passive ones, and thus they yield better results. In short, user behavior is more secure.
Now we're going to continue our interview with Lori Craner and talk about the phishing paper and other general lessons in usable security.
Yeah, so that paper, that's an oldie but a goodie, quite a while ago. I think by the time we got to doing that study, I think we had a pretty good idea that that we were going to see a lot of people falling for these attacks, and we had a good idea that Internet Explorer was particularly bad, and the data bore that out. I think the surprising thing for us was why people were falling for things. And I think one of the most surprising points, which I think we described in the paper, was the anecdote where we saw people who would get the warning in the browser, close the browser, go back to their email, click on it again, go back to the browser, close the browser, and repeat this like 8 times. And clearly they had a mental model that wasn't matching our mental model, because this made no sense to us. And then when we asked them about it, and it was more than one person who did this, they basically, it became clear that the browser warning was informing them that there was something wrong with the website. And in their mind, that had nothing to do with the email. The email was fine. There was just something wrong with the website. So obviously, if you go back to the email and click again, maybe the problem will clear up. And that they really had no idea of what the browser warning was really trying to communicate to them. Yeah, well, I think, it does speak to the importance of observing users and doing user studies, and realizing that users don't think the way you do. You are not your users, and so I think every time we do a study like this, we do have these surprising things that if we'd only talked to ourselves, we would never have figured out. And it really is important to talk to a wider group and not just people like you. So I think to improve the usability and security of systems, it's really important to think systematically about how users are going to interact with the systems. I think you want to go through from the beginning. What is the first thing you're asking your user to do? When do they do it? How do they do it? Walk through the whole process, write down all the steps. I think when you do that, you'll start to see in many systems, wow, there are a lot of steps here. And I think then you can start looking at those steps and saying, well, are these all steps that are really necessary to have the end user do? Is there stuff that we can automate and just have the system do automatically and not ask the user to do it? And which are the things that, yes, it's really important to have a live human being doing, and can we make those as pain-free as possible and as clear as possible so that the human is likely to actually do them properly and maintain the security of the system?